Good. So my name is Asaf, and I want to do a presentation here about Cabana 4 for log analysis. So like I said, my name is Asaf, and I'm the co-founder of a company called Logzio. We're actually presenting here, and we have a booth here, booth 815, if you want to stop by afterwards. Logzio is a log analytics company, and what we do is we take the ELK, which is the most common log analytics platform out there, and we offer it as a cloud service. And we also provide additional feature on top of it, which I'm going to talk a little bit about, but this is kind of like not the main purpose of this discussion. Again, there's two ways to get in touch with me here, either through Twitter or through email. And if you have more questions afterward, I'd be happy to answer any questions. And you obviously can get in touch with me. So what I want to cover in this presentation is a few things. First of all, kind of a brief introduction into the ELK, Elasticsearch, Logstash, and Cabana. Talk very, very briefly about Logzio, and talk about how to monitor cloud application, and I'm going to give an example of how we monitor our own application, which is obviously a cloud application. And then I want to dive into how do you take the ELK stack and turn it into a log analytics software, because just right out the gate, this is not enough what you get, and you will see it about what are all the missing components and how to take care of each one of them at a very high level and non-technical way. But still, if anyone wants to kind of dig in and go into the technical details, I'd be more than happy to address it and answer any questions about it. So what is ELK? So ELK is comprised of three different open source products. Elasticsearch, which is the E in the ELK. It's a schemaless database. It's mainly used for search. So a lot of sites, if you have a website, a lot of sites are using Elasticsearch on the backend to search, used for data analytics. It's highly scalable, so it can support a huge amount of data, not at the zero cost. I mean, there's obviously a cost of maintaining it, which I'm going to talk about. But it's highly scalable. It's very, very fast. Logstash, which is the L in the ELK, is basically sort of an ETL system. It takes data from one place, transforms it, and pushes it to Elasticsearch or any other database for that matter. It streams data, ingests the data. You can parse it and extract values out of it. You can enhance the data if you want to do a geolocation based on IP. If you want to do user agent, if you want to extract key values, you can do a lot of these capabilities using Logstash. So that's the L. And Cabana is the visualization layer. So Cabana is a very nice visualization layer. You can grow graphs, you can generate maps, you can do pie chart, and it's very robust from respect of different components that it has. So ELK is, just in number, is the #1 log analytics product out there. So it has more companies using it than all the other proprietary tools combined. So it's very, very robust, very well adopted in the industry, and part of the reason, which I think is probably the main reason, that this is open source. You can just take it, you can download it off the internet, free of cost, you can install it on your system, and you just run it as is. It has companies from all over the world. It has about 500,000 monthly downloads of the entire stack. Pretty huge community that's doing meetups and events all over the world. Companies like Facebook, like Netflix, like Microsoft Azure, like Cisco, like LinkedIn are all running internal kind of ELK stack internally. And if you can actually search for it, you would find different presentations, a different session that these guys, all of them separately, have done, and how they use Elasticsearch and how they use the ELK stack. The other thing is that if you look at this domain, and this is kind of like a research that we've done, if you look at the proprietary software, so it's companies like Splunk or Sumo Logic, Logly, or Log Entries, and there 40 other companies that are doing proprietary log analytics. They represent about 10% of the market. So when we talk to customers, we talk to users, 9 out of 10 are already embedding, are already using, are already invested in the ELK stack and are already using it. So this is a good reason of why to use that system as a log analytic. You are being supported by a very large community that take care of it and helps and provide information. So the good thing about the ELK stack is, first of all, that it's open source. So obviously it has no cost to you, and you can download and you can use it. It is very simple and it's very beautiful once you get it up and running and installed. The graphs on Cabana, the visualization layer, are very robust, very powerful. The UI is very nice, and once you get used to how to query the Elasticsearch and how to get the information out of it, then you get a lot of benefits from it. It's very, very fast. So, and the other thing which is not written here is very scalable. So whether you plan on ingesting 1 gigabyte a day or 1 petabyte a day, you can scale the environment to that level and be able to maintain decent performance of your queries, of your visualization, of all your data analysis. The downside of the ELK is that it's not production ready. I mean, this is an open source stack. You need to cobble together 3 different products, install them, connect them to one another. This is not meant for production. Though it is very scalable, and Elasticsearch and all the components are scalable, it's very hard to do it. And you very often reach a point where you cannot scale it beyond a certain level, or it's very difficult to scale. But that's kind of one of the things. It is scalable at a cost. And the other thing is it has poor security right at the gate. The platform is completely open. Again, this is a great open source project, but security was not part of it. Cabana, when you install it right out the gate, has no security mechanism, not even authentication, simple authentication to it. Same thing with Elasticsearch. If you end up exposing your Elasticsearch cluster to the public internet, you're going to get attacked in a matter of hours, and people are going to exploit it. So from a security perspective, it's relatively weak. So what we do at Logzio is that we take the ELK stack and we offer it as a cloud service. So you don't need to install it on your own. You don't need to set it up. You don't need to worry about how to scale it. All you need to do is sign up online. You get it up and running in a matter of minutes. It's scalable with how much data you send. So you can send 1 gig a day. You can send 1 terabyte a day. It doesn't matter to us. I mean, the system can grow and address these needs. It is obviously production ready. We run it in production. We monitor it all the time. We've also provided additional features on top of it. So we provided features like alerts, we provided features like role-based access, we provided advanced security, we provide high availability, and basically you get the benefit of enjoying all the good things with the open source, but actually have it running in production without the need to actually maintain it and set it up and upgrade it all the time. So a little bit about kind of like traditional application and cloud application. So if you look at the basic structure of a traditional application, you have your business logic, which usually runs on top of an operating system. You have servers, physical servers. You connect to a database or databases or different data stores and whatever you choose to use there. And you expose it to the outside world using front-end servers, using firewall, using load balancers, whatever you want to use, but you have a very static infrastructure that everything runs in one place. And it's very easy to find the logs because you log into the machine that runs your business logic and you find the log files exactly where they're supposed to be. And it's very easy to kind of open them, transport them, search on them, and this is kind of like a traditional application. If you look at cloud application, and this is just a very high overview of how we run our application. So we run very, very, very small pieces of business logic inside containers. We use Docker for that. We run all of it inside an auto-scaling group. We're using AWS for our entire hosting. Beginning to end, we're using AWS. and we run everything in auto-scaling group. We leverage the infrastructure level components that Amazon has. So we leverage the RDS, which is the connectivity to the databases, to be able to create a scalable infrastructure for the database. We leverage the ELB, which is the Elastic Load Balancer from Amazon, which is a scalable infrastructure that allows us to scale our front end. We leverage CloudFront, which is a CDN, and again, be able to leverage. This is part of the Amazon level configuration that you get, and part of the component that we have. We use a lot of other services that are not laid out here for messaging, for communication, for monitoring, and these are only part of it. The biggest challenge of this environment is that this environment is highly flexible and highly dynamic. So if we have an issue with one of our containers or one of our business logic that doesn't behave the way we expect it to behave, the first thing we do is get another one up exactly the same, replace that one, kill it, and that's it. The other thing is that with increased load in our system, we scale the system horizontally. So we add more and more servers, and when the load goes away, we scale down and we take out a few servers. The problem with that is that when you have a system like that, you're basically forced to run a log analytics system because your environment is so dynamic that without aggregating everything in real time to a centralized location, you have no way of making sense of what the data, because you cannot log into the server later on. That server or that Docker or that container or that business logic that you had, 2 hours from now, it does not exist anymore. So if you did not collect the information before you had the problem, during the time you had the problem, your ability to be able to perform troubleshooting on this, and your ability to analyze how the system was reacting at time of high load when the auto-scaling group grew, and how was the descaling of the auto-scaling group perform, without being able to extract all the information in real time to a centralized location, you have very little ability to be able to perform these actions. The other thing which we do in our environment, and we're talking to a lot of customers, a lot of people are starting to adopt it. This is a log-driven development, meaning that every developer that works for us, before he releases a feature to production, he makes sure to be able to say what are all the errors, what are all the warning exceptions that can come out of this model in different situations, be able to define alerts on it, set up all the metrics so we can track it, and he can track it on his own and say, well, I'm deploying a feature, I want to see how other people use it, so I'm going to define these metrics on it, create a full customized dashboard of alerting and metrics on top of it. So this is the reason we do it. This is all part of our kind of like DevOps transformation. The developers are taking ownership and responsibility of what they have in production as well. And this is the way we work in our environment, and it's proven to be very well working for us. So now I want to talk a little bit about log analysis with ELK. I talked about ELK being all these the three components. One of them does log aggregation, one of them is a database, and one of them is a visualization layer. So I want to take each and every component in the ELK stack and figure out what are the changes that are needed in order to transform this into an end-to-end log analytics service, and then we'll see what else is required there. So the first component is Elasticsearch. Elasticsearch is probably by far the biggest component in the ELK stack. It's the most difficult to be able to handle and manage, and be able to scale properly. It required a lot of attention, and it's obviously the basic of the whole data is being ingested in Elasticsearch, is being indexed there. So the ability to have a properly running Elasticsearch cluster or clusters is a requirement. So first thing you do is there's a lot of like OS level optimization that are required. Right out the gate, Elasticsearch comes with a pretty good pre-configured settings, but if you do want to run it for log analytics, if you do want to ingest a lot of data, then you would need to go through the operating system and set it up correctly. It's queues, it's buffers that you need to be able to set up, and log analytic work slightly different than any other kind kind of static or search that you would do with Elasticsearch, because you would be ingesting a lot of data in real time and you wouldn't be extracting a lot of data. The visualization take a lot less data, and the ingestion is fairly high volume. Second thing you need to take care of is index management. So Elasticsearch, like any search engine, has indices, and every index has the data inside of it. You cannot really delete data from a search engine, because this requires re-indexing of all the data that's already inside. It's a very complicated operation to do. And when you run log analytics and you want to be able to run, for example, I want to be able to run a sliding window of the past 30 days or 90 days, this requires you to run daily indexes in Elasticsearch, and then be able to curate them and be able to remove all the old indices, so you can always run kind of like a sliding window. You always have a daily index. You store your data in that index, and tomorrow you're going to store it in a different index, and so forth. Shard allocation, that's part of the optimization that needs to be done. Elasticsearch stores its information in different shards. You can impact the performance of Elasticsearch by doing different shard allocation, and it's also very important to understand that. Zone awareness, this is something which is very specific to Amazon. You want to run the cluster in a way that it has its replica shard at a different availability zone than you have the main shard. So this is an availability issue if you're running on Amazon. If you're running on other cloud provider that provide multiple zones, then you definitely need to be aware of how to configure Elasticsearch to be zone aware. Bulk insert optimization, again, you can always insert one document or one log line at a time. Obviously, this is not optimized. You can decide you want to do 50 at a time, 100 at a time, 5,000 at a time. This all depends on the latency and the throughput that you have in this environment, and this is kind of very important to be able to control it and be able to define it. And the last thing is cluster topology. So when you run Elasticsearch in a cluster, you're required to run at least 3 master nodes, because the master nodes are deciding how the topology works, and you don't want to create into what's called the split brain issue when they cannot decide between them. So you need 3 so they can decide kind of like who is the leader amongst them. You need to set up data nodes, you need to set up client nodes, and it's become a whole operation that you need to control how the topology is set and how the topology is changed, and what happens in discovery, and what happens when you add a node to the cluster because you want to grow it, and so forth. So this is obviously at a very, very high level how to be able to kind of take Elasticsearch and turn it into the ELK stack to be used in log analytics. The second component is Logstash, and I'm kind of trying to do by scanning it by the complexity of things, because obviously Elasticsearch is the most complicated and requires the most attention. It eventually holds the data, so you want it to be able to be resilient, but Logstash is just as complicated to be able to make it run properly. So first thing you need to take care of is data parsing. So a lot of the log files that are coming through it's unstructured data. So you need to define and you need to tell Logstash what is the parsing of the data, which field is the time field, what is the format of the time field, which fields are, how do you extract fields that have numbers in them, what's the format of the numbers, and so forth. If it has text in them, how to set it up. If it has an IP address in it, how to extract the IP. If you want to do geolocation, how to take the IP and change it to the geolocation. If you have data like user agent, how do you take the data and parse it to be able to distinguish the different operating system and the different browsers that are being used in this scenario. So all of it needs to be, you need to be able to go to Logstash and configure it. It's a pretty hefty configuration file to be able to kind of parse your data properly. Second thing you need to take care of is scalability. So Logstash is obviously stateless, takes data one end and transform it and end it at another end. But if you want it to be scalable, if you want to run a log analytics that scales into petabytes a day, then you will need to be able to run Logstash in a way that it's scalable, that you can grow it up or you can scale it up and down as you need. You need to have high availability. It's not trivial running Logstash in a cluster and making it highly available. This system, there are a lot of You need to have a lot of inner knowledge about how Logstash works, about its internal queuing, to be able to run it at a high availability system and be able to scale it in the cluster. The next thing is burst protection. So as you probably know, log files, when something's going well, then all the logs are pretty consistent, and you get a consistent volume of logs out of your system, whether it's going to be 100, 200 gigabytes a day, and it's all going to work fine. But when things go bad in the system, suddenly all of the environment is starting to scream that things are bad, and this is not connecting, and this is having an issue, and you get like a burst in the log files. So if you are running, let's say 10 gigabytes a day on average with log files, you may end up yourself doing 50 gigs in just 1 hour because all the system are screaming that things are going wrong. You need to be able to have Logstash support that kind of a burst. I can tell you that what the recommended way to do it and what we do is to front it with a messaging layer. So you can either use Kafka, you can use Redis, you can use Kinesis if you're running on AWS, but you need to front it with a layer that's going to absorb the sudden increase in logs without overloading the Logstash servers themselves, and to be able to control that load. We in our environment, we're using Kafka. We have a pretty big cluster of Kafka servers. We found it to be the most performing for the price that we have, and it's actually a very stable system. Next thing is configuration management. So one of the challenges with Logstash is that you cannot change configuration while the system is running. So if you, let's say you have a new log file, now you have to have data parsing for the log file. You cannot afford to take Logstash down, change the configuration, and get it back up, because by the time you take it down, change the configuration, and get it back up, you are going to be losing all the logs in the middle, because that's kind of like the entry to the system. So you would need to develop a system that takes it, stop it at some point. You can take it down. If it's a cluster, you can roll you can do a kind of a rolling upgrade, change the configuration, and be able to control it so everything is back online. And the last thing, which is kind of like one of the most critical things that happen in Logstash, is that when it pushes data to Elasticsearch quite often, and we see it from our customers and from myself, about 1% of the cases, Elasticsearch says, no, I'm not taking this document in, I'm not indexing it. So if you send 100 log lines, you're probably going to get one that is not ingested. So imagine if you want to troubleshoot a problem, and you go to it, and that one line that you're missing is the line that like you care most about and you need it. The reason this is happening is because Elasticsearch is a schemaless database, but it does define a schema once it sees the values. So if for a certain field you send the data as an integer, Elasticsearch says, okay, field A is an integer. Now in the next message, if you send that same field A is a string, Elasticsearch says, no, we can't put it as a string, and it just rejects it, and Logstash drops the message on the floor. The way to implement is that you need to capture this exception, and what we do is we push it back to Kafka. We have what we call a dead letter queue, so we push it into a queue of all the messages that did not get ingested into Elasticsearch. We serialize them as a text message, because we obviously cannot put that message back again into Elasticsearch because it's going to say no. We serialize it as a text message, push it to Elasticsearch, make sure it's properly ingested, make sure it's properly there, and then we take over the problem for the following messages. So we can update the configuration, but this requires a lot of attention on Logstash. Last thing, and I think I would say that the part that works the best in this configuration and this setup and require very little configuration is Cabana. So obviously you can use it out the gate. It works fine. It has no security and no other features to it, but it does work fine. If you want to add security, which we found and is very important, you need to either front it with a web server, so take like Nginx or Apache and be able to define settings to it. Second thing is role-based access. A lot of the time, many people in the organization are aggregating logs to a certain location, but you don't want to have everybody access all the information. If you do want to create a role-based access, this is an additional feature that needs to be created on top of Cabana. Obviously, high availability. Cabana runs in a Node.js server, so high availability is not rocket science. It's possible to do, and it's actually not difficult. The issue of alerts. So log analytics is very nice, but and troubleshooting is also very nice, but I want to get alerted every time something happens. I don't want my customers to complain about it and then me searching in the logs. Alerts is not part of the open source of the ELK stack, and you would need to implement it yourself if you're interested in running alerts. And the last two things have to do with the Cabana itself. So Cabana and Elasticsearch are using a search query that's called Lucene, which is based on Lucene search engine. And you can learn how to do it. It's not a simple language to do. You can get used to running queries in Lucene, and you can get used to building visualization and building dashboards and stuff like that. But then there's a lot of services that you can leverage actually to create pre-canned dashboards and copy it from other location. Same goes for anomaly detection. So what I talked about so far is how to take each and every component of the ELK stack and turn the whole stack into a log analytics service. So be able to run it as a log analytics service and be able to enjoy it. So the question is like, okay, I've gone through all of this. I take an Elasticsearch and I deployed it in a cluster, and now I have 10 servers that are running Elasticsearch, and I took Logstash and I deployed it and I put Kafka in front of it, and I make sure that all the messages are achieving, and I did all the parsing, and I got all the data, and I managed to configure Cabana for security, and I fronted it with a web server, and I created the role-based access and some feature of alerting on top of it, and I put it in a cluster for high availability and a load balancer in front of it, and I did all that work. I am left with probably about 15 different servers, to say the least, that are running log analytics for me. So now I have a whole system that I also need to monitor, both from logs and for availability. So I need to set up a monitoring system for my log analytics system. I need to be able to set up backup and disaster recovery. I don't want to lose the data if it happens, so I want to make sure that every time I have something there, I need to be able to set it up. So I need to be able to configure either to archive the data into an S3 bucket onto external data source. I need to be able to back it up continuously and be able to protect myself against disaster recovery. I don't know if any of you had experience working with AWS, but servers go down all the time. It's part of the norm of working with AWS. You have to adapt to it. You have to learn how to work in this environment, but it does happen all the time. And the last thing is upgrades. Obviously, this is an open source project. This means that every upgrade, not every upgrade, I would say, has backward compatibility. So for every time you want to upgrade Elasticsearch from 1.5 to 1.7 to 2.0, you would have to do the work of setting it up yourself, making sure what are the differences between these two versions. Is it going to work? Is it not going to work? How do I upgrade my cluster without affecting the data? And so forth. So for example, when Cabana, they went from Cabana 3 to Cabana 4, there was no way of moving your visualization and all the work that you've done in Cabana from 3 to 4, and you would have to build it all yourself. And this is a challenge that you would need to address when working with this stack. So this is what I want to talk about, and I want to know if there are any questions about it and kind of like how we use it internally. I can barely see it, but is there any questions? Yes?
So my question is, you outlined that the open source products are available and usable. You outlined some shortages. Is the typical path to somebody decide to use your stuff that they've already tried themselves and then throw up their hands and said this is really rocket science?
Not really, because it doesn't sound like rocket science, but the typical stuff is there are a lot of companies, a lot of them, that are taking the path of setting it up themselves. And they take some shortcuts in the way. So if you're setting it up yourself and you don't care about things, you don't have to set up Elasticsearch on multiple availability zones. You just say, okay, it's in one availability zone. If things go bad, you don't need to take care of Logstash and the configuration changes, because you say, okay, you know what? On a Saturday, I have no one sending logs in my system. No one's logging in. I'm going to take the system down, upgrade configuration on a Saturday. So there are a lot of shortcuts you can take along the way if you want to do it. If this becomes a main system in your environment with 24/7 environment that you rely upon, then it is going to be a little bit more complicated. But there are plenty of a lot of customers, a lot of users that are using Elasticsearch as is, without any configuration changes. Any more questions?
I've got two questions. First one is, can you compare your service with Splunk? What additional stuff you do? And the other one is the logs are very critical. So what if I'm not okay of hosting my logs in the cloud, and do you have something that I can deploy internally?
Yeah. So these are two great questions. So compare ourselves to Splunk. So I think we started by saying is that this is an open source system, and it leverages the power of a huge community that's contributing and making things better. We actually have just released a research that we've done on Splunk specifically and the ELK stack, and we did something very interesting to figure out how popular each platform is. And what we did is we looked at Google Analytics for the past, I think it was like 4 or 5 years, and the trends that what are people searching for, and you see that you actually can see it. And if you look at InfoWorld, you can see our article saying where kind of Splunk levels off, and kind of like Elasticsearch and the ELK stack takes off. It is a huge community. I have to say, though, that from a functionality perspective, Splunk is a very functional product. It has a lot of features that the ELK stack does not have, and it's a much robust system. The other thing is, I do not have a lot of experience with Splunk from a scalability perspective, but we have quite a few customers coming to us and saying, well, they run a huge Splunk cluster, and this is becoming too much of a hassle for them to manage as well, too expensive to own the software, because you have to own the software and you have to pay for the hardware or the hosting to do this. And they're looking for a kind of like a different solution that's just as functional. The other question is like whether we offer it kind of like on-premise and sending the data to the cloud. So we are in the process of kind of like getting compliance and going through all of this, but right now we offer it as a cloud service. We do have quite a lot of customers that have compliant, and what we do with them is that they obfuscate or remove the data before they send the data to us. So some of the data that they don't want to be ingested, like PIIs, like personal information, like credit card information and stuff like that, they just strike it out from the log files, and obviously, it's a great practice not to have it in the log files to begin with, and you can leverage it by that. But we do offer a cloud service, and you can still take the ELK stack and set it up on your own in your own environment, and it works great. Any more questions?
There's one question I had. Elastic as a company, they also have some of the commercial plugins that they have developed, like Watcher, Shield, Marvel. Yeah. So how do you compare yourself with those offerings that essentially they're trying to transform ELK as an open source stack to a more enterprise-grade stack?
Yeah, so Elasticsearch, they definitely have additional features like Watcher, which is their alerting system. They have Shield, which is enhanced security for the database level, and they are making it. The thing is about, and they're definitely, they're a great company supporting the great community of Elasticsearch. From a cost perspective, we decided to kind of implement that stuff on our own. If you look at their pricing model for all this, and this is not something that is applicable for a lot of organizations. You end up, if you do want to buy all their extended features and all their support and services, you end up paying quite a lot of money per server, which is a challenge. The other thing which they have, and it's also available now from Amazon, is what's called the hosted Elasticsearch. So they take the piece in the middle, which is the Elasticsearch, and you give you the ability to provide a hosted Elasticsearch, meaning that you say, I want to have 5 data node Elasticsearch with 3 master node, and they set it up for you completely, and you can decide how much storage, how much memory in each one of them, and they set up the cluster for you. The challenge with that is that this leaves you, I think it's a great step forward, but this leaves you with a lot of the heavy lifting still to do. So you still need to do index management and curation, and you need to take care of Logstash and all the pipeline and the burst protection and the ability to parse the data properly, and you need to be able to set up Cabana and the security throughout the way. Their alerting system is not integrated to the Cabana, so it is a powerful system, but you need to know the JSON structure of Elasticsearch query in order to run, to define your alerts. So all of it is part of it. What we're trying to provide is provide an end-to-end solution of the ELK stack, meaning you sign up on the internet, you ship the logs, everything from now on you're doing through the user interface, and you're getting kind of like an end-to-end ELK stack, so you get the benefit of always being with the open source, and you get the benefit of it actually working. Okay. Thank you very much. Thanks for coming.